let's try today's question. Oh, okay, from now on I think I'm gonna try, because the videos can get long, I'm gonna start using the timer. Once I spend 30 minutes within one question, then I'll probably just end the question there, for the video at least, and then I might work on it later on my own. Just so that I can just make it uniform, all the videos time-wise. If I end early, then I don't need to make a video from then on, but if it's not that, if it goes over 30 minutes, I'll try to just end it there from now on. Okay. Today, instead of following this roadmap from LeetCode, I'm gonna just get an easy question. Don't know, sometimes LeetCode problems, even with the tag, the easy tag, it's not that easy per se. So hopefully that doesn't really mess up with how I solve this question. Okay, this one's merge sort, so pretty just, do I know my algorithms? Is what I'm understanding from here. Okay. You're given two integer arrays, nums1 and nums2, sort in non-descending order. The two integers m and n represent the number of elements in nums1 and nums2, respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. So, okay. The final sorted array should not be returned by the function, but instead be sorted inside the array nums1. To accommodate this, nums1 has length of m plus n, where the first n elements denote the elements that should be merged and the last n elements are set in 0 and should be ignored. Nums2 has the length of n. Okay. How should I imagine this? Okay, and then okay. Can you make this algorithm run? For loops. One for loop m, one for loop for n, or m and n. I'll just make an index for n. Well, okay. That. Okay, let's see. I'll just have this open just in case I need to draw out my thoughts. 1, 2, 3, 0, 0, 0. Can the integers also be 0? They can be. Oh, so this is m here. This is n here. And n is like, we'll just check the first one. 2, 5, 6. This is n. So even if there is a 0 here, the m would be able to take it, right? And we'll have some type of for loop that iterates through this, and something that iterates through this. So for m, and then also for n. That'll give us, no, that'll give us mn. Oh. Whoops. Well, let's not think about that first then. we'll just think of how we can somewhat compare these two. We can have an index for n, for the second one, start from 0. And then while we iterate through this one, so from here, we compare. Is it we want it non-descending. So we'll just compare this one, the first one, and this one. And we're like, no, change it. We'll send, if this is, since this is greater, we'll leave it. We'll iterate to the next one. Compare. Since it's the same, it's non-descending, so we'll just leave it. Go to the next one. 3. Compare. 2 is smaller. Save this into a temporary storage. Shove this in. Iterate this by 1. Then check here. Temporary. Compare. Oh, this goes in here. So how do we do a check to make sure that we've gone over everything here? These ones at least. If the current index while we're looping through this one is greater than m, maybe, is what I'm thinking, because we know that nums1 and nums2 is gonna be sorted in the way that it wants us, in this way, like 2, 5, 6, nothing, 1, right? So you don't really have to worry about that, right? So we can have a index for m count, which will iterate one at a time every time we pass by, and then somehow this number is used or stored in a temp, right? And then once this reaches m, that's when we say, just append whatever is left to the end. Once, when temp is nothing. Can we set temp to nil? Let's see afterwards. But yeah, once you've gone through this, and temp is whatever. Okay, let's try that. So for IV, so index and value in range nums1, this will be what we use most. We'll have a variable called temp int. We might have a variable called temp int. We'll have an index 1, index 2, which are all integers, right? These will all be set to 0, okay? One thing we need to check is if our current index, if index 1 is equal to 1, equal to m, then nums1 is going to equal wait. Let me double check. Okay, how will we do this? 2, 3. gonna iterate through this, okay? We're gonna iterate through this while we're doing checks. In the first one, let's say index m is also equal to 0. Okay, we'll iterate through the first one, compare, okay, 1, 2, 2. Temp has nothing, so temp has 0 here right now. 3. This is put into here. So we have 1, 2, 2, 0, 0, 0, 2, 5, 6. Put the pointer here. And then now this has 3, temp. And since temp right, we've iterated 0, 1, 2, so we've basically traversed through all the integers that we have, right, that we're given. Oh, wait, let me try this one. 2, 5, 6, 0, 0, 1, 2, 3. This might be a better example to understand this from. Okay, 2. This is great. This is better. Then we have 1, 5, 6, 0, 0, 0, 1, 2, 3. With 2 as a temporary. Next, 2 is here, 2 is here. Let's take a look here. Compare from here. This is not greater than this, so we put 2, 6, 0, 0, 0, 5, 1, 2, 3. Right? At this point, from here, while it's going through index m is gonna equal, from here it's 0, blah blah. From here, 0 and 0. Index m. Index m is 1, right? M is 0 because we haven't spent it yet. Count m might be count 1 might be there. Whoops. Count 1 just to make sure. Okay, let me try this then. Not the best. So how this will go is the comparison is gonna be if nums2 index 2 is greater than the value, if this is true, then we're gonna set temp to equal v, which will hold, and then we're gonna set index 2, increase it by 1. Right? That's one thing we have. If temp can we set temp to equal nil? Oh, I'm using nil. That's one comparison. The other comparison would be if nums2 index 2 is greater than temporary, then temp remains the same. So here, if this is the case, temp equals v, nums1 in the current thing will equal the value in nums2, right? And then we'll put that in. And then what happens is we'll store v for later comparison and whatnot, right? If nums is greater than temp, temp will remain the same. We'll set like this, right? If not this is greater than temp, we'll switch whatever to this, and then we might want to make temp an array actually. Temp var temp is an array of integers, right? Temp equals append temp with if that doesn't work, if there isn't, then we're going to append v to temp, right? And increase it by this. So this can only work if temp is nil. If there is something in temp, then we need to check it. Therefore, this would be called, right? This will only work if temp is empty. If it isn't empty, then we'll check this. Okay. So I guess we can continue here, right? I'll just have it here for now. If that condition isn't met, else if, we'll compare this to our first thing in temp. So if this is the case, then temp will append the value to the end of temp. And we'll do that, and then we'll set the index. Else, if this is not the case, then we'll not increase index 2, we'll increase count 1 to make sure that we've, count 1 will increase by 1, right? And then we'll set temp to equal temp everything from index 1 and over. So it'll get rid of the first one, the head of the list, of the array. Not list, array. We're gonna, we have to first change nums, whatever this is, with temp 0. We'll do this, and then we'll finalize it with this. So here at the end, we'll do a count. If count 1 equals the number of integers in num1 we have, then we can return Would that be better? Ah, okay, no. Index 2. Yeah, so if count 1 is equal to m, so we've traversed all of list 1, right? Then we can just return whatever's left over, right? Then we can say nums1 equals append nums1 from the beginning to our current index, and we'll append it to nums2. We'll append from nums2 index 2 until the end. This makes sense, at least for me right now. That's one thing, right? We also need to do a check if we've gone through if, and then we can just break it. We can just end it. If index 2 plus 1 equals n, also we can do nums1 equals append nums1 from whatever index we have, and we can add temp, whatever is left in temp, and this should work, or at least the logic is there. Index out of range 3. Okay, let me double check how this works. Why did that happen? This should be easy. But where's my logic coming from? Okay, let's think of this again. We're going. Let's think of this example. Nums this one, right? We come here. We're going through this. Oh, since index if n equals 0, nums1. It's only used for loops. Okay. From here, do it. If n is equal to 0, so I can, instead of what we did just now, I could just use n here. If n equals 0, nums equals nums1 equals nums1. Append nums1 and nums1 with temp. Right. This is gonna be if nums 1. So this one is if m is 0, nums 1 goes append. This one also, we need to make sure that it's until k, wait, until I. So we've checked everything. And if m is 0, that means we've done everything to what we can do. And then we'll add nums 2 from whichever index we left off from, right? I'm not sure if I want to keep the index 2 or well, why not? Let's try this first, like index 2 from index 2 and onwards. Okay, we'll just leave it like this. This is if conditions are met. This is what I'm guessing. And then we're gonna break it. We don't need anything else from here. So these conditions don't really matter now. Next, we're gonna work on this part. Let me double think about this. So, what's gonna happen is, if our current value is less than, or let's say if the value in nums2 of our current index 2 is less than v. Is less than v. That's only what we need to worry. Or temp. The first existing thing in temp. That's all that we need to worry about. Anything else? We can just pass. Right? So these are the only conditions that we need to really think about. Let me just say, if nums2 index is greater than or equal to whatever v or temp we have, we're going to decrement as m by 1, so that this can make sure it runs by m by 1. And then we're just gonna move on. If in the case it's temp, then we'll do another whole thing here. In case it's temp, we'll do something else. Some other logic. So here, if this is less than v, while temp is nil, right? This is important. That shows that there's no value in the array temporary. We'll append our current value that was greater than this to temp. Now temp is greater than this, right? This, right? We'll set the index of nums1 to this value in our nums, right? We'll increase index 2 by 1, and then we'll decrement n by 1, so that we can get closer to this. If this doesn't work, then we have the case where this is less than the value in temp, right? Then we can just break here. If this is the case, then we'll append the value of v to temp, because we know if there's something in temp here, we know that v is for sure gonna be bigger than the value in temp. So this, we're gonna set that to this, we're gonna increase this, and then we're gonna decrement it by 1. Else, meaning this is indeed smaller than this or equal, we're gonna set this to this. We're going to do that. We're going to, make a slice of our current temp so that it starts from the second element to whatever it ends. It could be, that could be the only one that's left, or whatnot. And then decrement m by 1. For sure, I can get rid of index 2. 3 index 2 equals 3 minus len n. Will break. I don't think we should have all these breaks. If none of these work. Oh no. If this should only run if there exists, if we have something, right? And that's the case. Oh no, 1 minute left. I feel like I'm so close. The logic here is what's causing me some pain in the ass. I don't feel like it should be easy. I'm thinking. Instead of adding temp, should I just swap it with nums 2 and nums 1? So if I have 1, 4, 5, 0, 0, 0, 2, 3, 6, right? We check this. 1, 4, 5, 0, 0, 0. At this, right? 2, 3, 6. Now we go to this. We're still this. This is still smaller. 1, 2, 5, 0, 0, 0, 4, 3, 6. No. That doesn't work. Then this complicates things, right? this is smaller than this. Right, so if my thinking was still the same, right, what will happen is, let's do this. We swap 3, 0, 0, 0, 4, 5, 6. This could be 4. 4. That's why that swapping might be too dangerous. Yeah. Then 30. No, I'm gonna try solving this. I feel like it's a very simple answer, but I'm trying to overcomplicate things. Yeah, so if there's no more integers add to think of, then we'll just append whatever is left in temporary. We know for a fact that temporary is going to be still sorted, so we'll just attach at the back. If m is equal to 0, yeah, then whatever index we're at, we'll just add it there, and then we'll, chuck in whatever is left in nums2 to the back of it, not I plus 1. Yeah, and then that should be the end of it, right? And whatever logic we have left to do is to make sure all the sorting magic is done properly, right? Okay. Else is gonna be, right? I'm just gonna do else is gonna be m decreasing by 1, index 2, nothing happening to index 2, right? It's just gonna be this. It's gonna be m decreasing by 1, and that's it. Yeah. That's what's gonna happen. Let's just do this. If this is the case, so if this is the case, else if this is a case where temp is not null, we'll do this. Else if else if no, yeah, then else. No need to add the break here. Right. So these are the conditions to just end it. Until then, we're going to compare. If the index in nums2, now if the value in nums2 is less than v, we want to merge it into nums1, then we're going to set the value in temp to our temp array. Now in nums1 to our temp array, we're going to change the value in nums1. We're going to increment index by 1 and decrement n by 1. If temp is not nil, so there is something in temp, then we'll do this. And then else if, so this all gone. If the temp is not nil, if there is something, we'll do this. If not, we'll just do that. Okay. logic wise, fuck's sake, where is it? Index out of range or not with length 0. And this one, I'll just put this in front. Oop, what's happening? 1, 2, 2, 3. What's happening here? Something over here. Let's look at this one. Zero. So m equals to this. So we're at 0. We're gonna append. Oh, how should I do this? This one. If m is 0. I feel like that's not making sense here. That's not gonna work. Oh, that does work. Maybe, let me check. 0, 1, 2. Let's do some. Two not figured it out. We're gonna go through this. Temp. Two, 0, 1, 1, 1. If since temp is empty and our thing is less than our value, we're gonna add 2 to temp. We're gonna add 2 to temp, and then we're gonna set this to that. So when n equals not, also should work, and that should fix it as well. Okay, wait, what happened here? One, 2, 4, 5, 6, 0, 5, 3, 1. Okay, so this one is 1, 3, 4. This goes to 4. 2, 3, 4, 4, 3, 3. This goes to 0. That goes to 3, and then we'll have temp have 4. And then we also have to now, we have to compare 4 to 5. No, okay. We have to do this. We have to add whatever's in temp, and then we also have to add whatever's in nums from I plus 1 and onwards. And then it won't matter if we have this because we know that, oh no. Nums. Oh shit, wait. Can't have this. Nums 1 equals n nums 1. Let's start to I plus 1. 2 nums I plus 1 and onwards. We append that. Oh, wait. Temp 2. It's gonna be nums 1. Slice it from I plus 1 and onwards. And then temp 2. Should work. What does this mean? We got 1, 2, 3, 4, 5, 6. Huh. Yeah. It wouldn't matter for n equals 0. 4, 5, 6. Oh, wait, what? Why am I getting here? 4, 5, 6, 0, 0, 0. 3. 1, 2, 3. 3. Okay. How does this go? I'll check. It'll go like one should go here. This decreases 2. Temp gets 4. Temp is 4. And then 2 is smaller than this. 2 goes here. 5 goes here. This goes decreased by 1. 3. 3 is less than 4. 3 goes here. This becomes 0. And this gets 6. Oh, this is 0. Therefore, we should add whatever we have. We know this is like this, right? Temp 2 append nums 1. So this would be nums 1 1 2. Oh, what? Because nums 1 is already going to be that, right? So we don't have to worry about nums. Okay. just... Oh, it's reaching 45. Oh, okay. No, my head. What? Okay, 10. Or essentially, what's gonna happen is, whoa, plus whatever's left in 10. Right. And then we add whatever's left. Right. 4, 5, 6, 7. With this idea, I could, instead of this, I could set temp equals append nums temp, and then nums1 from I onwards, right? And then I'll set nums1 equals append nums1 until I, and then temp. That would be better actually. Cannot be used. Use known value of type. Oh, same issue. Well then there's nothing that makes it 10. 10 of 10 this. Go playground. Each time I want you to from theta print ln nums 1 temp to do this, and I want you to send this. Since we realize that, oh, n is equal to 0, we'll set temp. How does temp look here? The end. Okay, temp is that. Then I want you let's see. No, that's not the case. I can't do that. Oh no, it's not the wrong one. This doesn't make sense, isn't it? Because it's the first one, right? Right? We're sending whatever is left here, right? To the end of temp. And then we're going to append nums this temp to nums1 from append nums1 all the way to the end. Sort nums1 from the start to the end. Why is this the case? That's not okay. Right? Okay, I think I just don't know something well enough about Golang. I need to double check how this works. So I'll end the video here for today's work. I'm gonna finish this up, figure out why this isn't working here, and I'll see you guys tomorrow if I solve something tomorrow. Bye bye, peace.